Okay. So good afternoon, class. Okay, for today we're going to discuss some final exam questions. Okay, we have we discussed this question in class?
No.
No. Okay, so we will discuss this question in class. Yeah. Okay. Now, a flywheel of radius 0.2 meter is initially at rest. Okay, so hold on. Can you see my screen?
Yes.
Yes,
Okay, yes, okay. So it says it is initially at rest when subjected to a force P equals to 10 Newton as shown in figure question 4a. The flywheel has a mass of 60 kilograms and a radius of gyration of 50 mm. Now, the question is determine the time for the flywheel to reach an angular velocity of 50 rpm. Okay, this is 7 marks. Okay, so how are we going to solve this question? Okay, what method do you want to use to solve this question? They ask you to calculate the time. So remember, I have mentioned to you there are two methods, two principles that we can use to solve problems that are related to rigid body. One is principle of linear impulse and momentum, and the other one is principle of work and energy. So for this question, what method you want to use? Which principle do you want to use? Can you please let me know?
Impulse momentum.
Yes, that is correct. So what we're going to do is we're going to use the impulse and momentum. So for impulse or momentum, it's very simple. We need to draw three diagrams as I've told you before. The first diagram is for system momenta 1, okay, plus, okay, sometimes you can do system momentum 1, sometimes you can use system angular momentum 1, okay, it means the same thing, okay, plus system impulse 1 to 2 equals to, oops, the circle is a bit too big, equals to system momenta 2. Okay, now, so we have drawn the circle. Let's draw the center of the circle, a dot. Okay, now, so for this question, because it says a flywheel, it has a radius 0.2 meter, initially at rest, subjected to a force P. So basically, there is a force P that is causing it to rotate. So there is a rotation on the of the flywheel. So let's say the flywheel rotates. So when it rotates, what we will have is I omega. Okay, so this is I omega 1. Okay, and for system momentum 2, we will also have the same, which is I omega, but I omega 2. Okay, all right, and then for the system impulse 1 to 2, so we have to look at what external force that we have. So the external force that we have is the force P. Okay, 10 Newton. Yes, 10 Newton. So the P is 10 Newton. Don't forget we need to multiply by the time T. So that's why we write a T there. Okay, and the other thing that we have here, of course, we have due to weight, mgt, and then we also have a resultant force, RT. But however, for when we want to put into the equation, we only multiply the moment or the force with the radius r, but we don't take note on with the value of that is at the middle dot here, which is the weight and the resultant force r. We don't the normal force r. We don't take note. We only take note what is the force that can be multiplied by the radius r. So that's why we only take note 10 Newton. Okay, so this is the radius. Is it 0.2? Yes, 0.2 meter. So when you put into the equation, it will be I omega plus I omega 1 plus impulse 1 to 2 equals to I omega 2. Now, since this question it says it is initially starting from rest, so what it means is, what does it mean? It means I omega 1, we can assume it as 0. Okay? Plus, what is the force that we have? We have 10 T, and don't forget we need to multiply by R. Okay, equals to I omega 2. Okay, now do we have the value of I, which is the moment of inertia? We do not have in this question, but we can find it, right? Here, what is the clue that it gives? Okay, I've mentioned to you before, in order to calculate I, you can use I this, which has the formula 1 over 2 mr squared, or I this equals to mk squared. Now, for this question, since it gives you the radius of gyration 50 mm, which formula you want to use? The first one or the second one?
I this. MK kuasa 2.
Yes, that is correct. Good. So basically, we have to use I this mk mk squared. Yes. So let's calculate that. So what is our mass? Our mass is 60 kilogram. And what is our K? Our K is given as 50 mm. So this one you must change unit to meters. Please be alert. Jangan, don't forget to not change it to the correct units. Okay, can you please multiply 60 multiplied by 0.05 squared?
0.15.
Okay, so what is the unit? It must be kilogram meter squared. Yes, that's correct. So we have 10. Our time, okay, time is the what they ask us to calculate. Our R is our radius. So our radius is 0.2 equals to our I. What is our I? Our I is 0.15. And then and then we have to find omega. Okay, just give me a second. All right. Okay. Mm, okay. All right. Sorry. Okay. Now, what is our omega 2? Do we have our omega 2? Do you have?
Yes.
Okay. Here is given angular velocity, which is omega, which is 50 rpm. But you have to change the unit to radian per second. So how do you change 50 rpm to radian per second? What do you do? I have taught you how to convert it, right? What do you do?
Yes.
How do you do it? I can
Uh,
hear you flipping your book. Nasib baik open book kan?
uh-uh.
Itulah.
Doktor, bila dah convert 50 RPM tu dapat 5.236
Okay, betul. Tapi I tanya you sekarang, how do you convert it? 50 RPM to radian per second, what do you need to multiply or divide?
Times 1 minute over 60 seconds times 2 pi over 1 rep.
So, 50 times 2 pi over 60.
2
Is
pi
that
over
right?
60.
Okay, so what do you get just now? You get 5 point?
5.236.
Okay. So you,
236. Doktor,
okay, so hold on. 5.236 radian per second. So here what you need to do, you need to multiply it with 5.236. Okay, all right. So can you find me what is T? So what is the answer for T?
0.393.
Okay, so 0.39 seconds. Okay, so that is the answer. Okay, that's correct. Okay, so that you get 7 marks. Okay, so for this question, you will get 7 marks. You get the marks for drawing the diagram. You will get marks for writing the equation correct. You will get marks writing the values, putting it into the values correct. And finally, you get marks for the correct answer. Okay, good. All right, now let's go to the second question. Now, the second question is determine the angular velocity. Now, this second question, they ask you to calculate the angular velocity omega when it has reached 50 revolutions. Okay, now, which method you want to use to solve this problem? Now, the clue is 50 revolutions. 50 revolutions is for what method? What principle? Now, remember I've told you for work energy it involves position, displacement. Did I mention that? I mentioned that, right, for work and energy. So 50 revolutions is theta. So for this question, number 2, what you need to do is you need to use what? Work and energy. Are you clear? You need to use what?
Work and energy.
Yes, work and energy. So for the second question, you need to use work and energy. It will be the same thing. Okay, it will be the same thing where you need to draw the circle again. Okay, you will draw the circle again. All right. Okay, so for this question we're going to use work and energy. Yeah, work and energy principle. For this question we're going to use principle of work and energy. This is question number 2. For question number 1 just now, what we did was we used principle of impulse. Oops. Let me principle of principle of impulse. Okay, and momentum. Okay, this is for the first question. Okay, now we're going to go to the second question where we're going to use work and energy. Okay, now, so for this question, it asks us to write what is omega. So for this question, it will be the same. So there is draw a dot at the center. Okay, and then it will say there will be a rotation due to omega, omega 1, and again rotation due to omega 2. And the difference here, there will be same force P of 10 Newton, but then what we want to find is the angle theta. Sorry, we want to find omega, but based on the angle theta of 50 revolutions. Okay, and this is R, the radius, which is 0.2 meter. Okay, so we're going to use work energy method. So if you remember, work energy method is what? T1 plus work 1 to 2 equals to T2. Okay, now since this is the same question and it starts from rest, so automatically our T1 will be 0. So you can always write T1 equals to 0. Okay? All right, now, so what is the work involved in this question? Okay, now, so the work involved in this question is again the same, which is 10 newtons multiplied by the radius r, but we need to multiply by theta, okay, equals to the kinetic energy. So for this one, the kinetic energy, if you remember, is what is the formula for the kinetic energy? Do you remember? 1 over 2 what? I?
Abyss. Oh,
I omega square.
Omega square.
Yes, don't forget there is I omega square. This omega is for omega 2, yeah? Okay, now, right now, do we have theta? Okay, we have theta, but our theta, we need to change it into our theta. We need to change it to radian. Right now is 50 revolutions. So 50 revolution change to radian. How do you change that? One revolution, berapa pi?
2 pi
Yes, 2 pi radian. So if 50 revolution, it will be 50
100 pi.
times
100 pi radian. Yes, that's correct. So it will be 100 pi radian. Okay. Pertukaran unit ni, yang ni semua ni is very important All these things, pertukaran unit, all this change of apa units, all this is very important because if you do not do it, then if you do it wrong, you will lose marks So okay, let's go back here. Okay, so oops, we have 10. Okay, and then we have R. Our R is 0.2. And then we have our theta in radian, which is 100 pi. Okay, and then what we have is 1 over 2. Our I we have calculated earlier, which is 0.15 kilogram meter squared. And what we need to find as our unknown is this omega squared. So can you find me what is omega? Your answers should be in radian per second. Okay.
91.53 ada.
Okay, betul. 91.
Radian.
53 radian per second. Okay, that is correct. Okay, so that is how you answer the question. You need to apa? It's to me subject rigid body ni is actually more easier than the earlier topics before. Because all you need to do is identify which principle you want to use, and then from there you look at the questions. Okay, so if you notice for question principle of impulse and momentum, principle of work energy, the diagram is only different. It can be a circular disc, and maybe the circular disc has a weight, or the circular disc has another disc. Like the previous question we do, there is two cables or whatever lah. So, but however, the concept on how to solve it is the same. Okay, as long as you know what formulas that you need to use, it should be fine. Okay, all right. So this is how to answer that question. Okay, all right. So can we proceed to our next final exam questions that we're going to discuss today?
Yes.
Okay, where is the other one or this one? Okay, let me just copy. Okay, so we did this one already. We discussed this one, and this one you should be able to do. We did not discuss this one, but I think you know how to do it. It's the same method as this question. Okay, betul tak? Do you think you can do this question by yourself, or you still want to discuss? What is your
Discuss boleh doktor?
Tapi soalan ni exactly the same dengan atas ni. Cuma gambar dia je lain. Nak discuss
Oh,
juga? Manjanya. Okay, never mind. Okay, kita can discuss. Okay, but we discuss just apa? Just in brief boleh? Just discuss in brief how to do it. But in the end, I expect you to try to solve it by yourself. We can discuss, no problem. Kejap, saya nak tengok ni. June June 2012. Okay. Okay, give me a second. Okay, all right. Let me copy this question using snipping tool. Okay, where are we? All right. Okay, now for this question, okay, there are two blocks. Block A and block B are connected by two cables to a double pulley and start to move from rest, okay, on a smooth incline at 30 degrees as shown in figure question 4A. A is connected through the outer radius. So kalau you notice, dia ada trick kat sini. Cable apa ni? Block A ni dia connected to the outer radius, and uh, is connected to the outer radius of pulley, and B is connected to the inner radius. So jangan tersilap, ya. So kat sini kita ada kita punya pulley ni. If I draw balik, okay. So this is how you draw. When you draw balik, if you know, oh sorry, silap. If you draw back, if you notice, the block A is connected to the outer radius, and the inner and block B is connected to the inner radius. Inner radius. The outer radius is what? 0.2 meter. The inner radius is, oh sorry, not 0.2. Sorry. The inner radius, sorry, the outer radius is 0.02 meter, and the inner radius is 0.01 meter. Okay, that is just the difference, yeah. Okay, now, so for this question is actually, let me finish reading the question. The pulley rotates counterclockwise direction. Okay, now counterclockwise direction. So, what does it mean, counterclockwise? So, if this is your counterclockwise, so what happened to block A? Will block A go down or block A go up?
So A go down.
Yes, so there is a clue here. The block A will go down, okay? So when block A goes down, what happened to block B? Block B will go up. Okay, if one goes down, the other one will go up automatically, yeah? So here there is a clue here. You make sure you alert with this thing in the question. Now the pulley has a mass of 5 kg and radius of gyration of 0.2. So this pulley also has a weight, which the weight is 5 kg, and it has radius of gyration k dia 0.2 meter. Okay, now for this question, what we need to do first is, let's read the question. Based on your free body diagram, determine the equation of motion using Newton's second law for the blocks and pulley. So sama dengan question yang sebelum ni yang kita dah discuss on last Monday. What you need to do is you need to come up dengan three equation. One equation for block A, the other one for equation for block B, and lastly the equation for the pulley. And again, for this question, it says use Newton second law. So you need to use Newton second law, which is equal to F equals to ma, and it says based on free body diagram. So what we need to do now is we need to draw the correct free body diagram. Okay, now let's draw the free body diagram. Okay, first block A, there will be a weight pointing downwards, vertically downwards, and also you will have a normal force like that. Now for this question, do we have frictional force? Do you have frictional force? Yes or no? Can you please answer me that? For this question, do we have frictional force?
No.
No. Why no?
Sebab dia tak cakap kot.
No,
Sebab dia
dia
cakap
tak.
smooth plane.
Yes, dia cakap the clue is smooth plane. Due to the smooth plane, kita tak ada frictional force here. So jangan lukis frictional force tu, ya. Okay. So next, block B also will have a force pointing vertically downwards, W, and then kita also have a normal force N lah, as usual lah. Okay, and then after that, because there is a two cables here, you need to draw the cable. The cable will be behave in tension, and tension is pulling the block. So let's say this is your block, you're pulling it. Okay, so this is tension. So let's say we label this as tension 1 lah. Okay, this is tension 1, and then this is the other block. Let's say this is tension 2, this is tension 2. Okay, now since you have this diagram complete, then only you can write down the correct equation. So how do we write the equation? Okay, so very simple lah. You have to use apa summation forces F equals to MA lah. Okay, so let's say we're gonna do for block A. Okay, now for block A, let's say F equals to MA, where you are going to assume going downwards, okay, as positive, eh? So F equals to MA. Okay, now when you go downwards, it equals to positive. So what do you need to do? You need to resolve all in the same direction. So this W, you need to resolve into this direction. So what it will be? It will be
Co-
W.
Cos is cos 30.
Ah,
Sin 30 eh?
sine 30. Okay. So it will be W will be mg lah. M will be 10, and then G. Okay. Sine 30. Okay. Minus T1 equals to 10 A. Okay, again, because this is a rigid body, I have taught you before for the acceleration for A, acceleration for block A, it will be R alpha. So our R, we need to use the outer or inner radius for block A. For block A, because it's
Outer.
outer. So outer is what? 0.02 alpha. So again, it will be 10 g sine theta minus t1 equals to 10 0.02 alpha. So very easy. Okay, so that is your equation. So all you need to do, you just put T1 as the main answer, and you calculate it, you get 49.05 minus 0.2 alpha. Okay, all right. Okay, now because our acceleration is going downwards, that's why we assume downward as the direction we assume as going down as positive. Now let's look at block B. Okay, now block B, the direction of the acceleration is going up, so you can assume the direction of going up, F equals to ma going up. So what would it be? Okay, so again it will be very
For
simple, T2 minus yes, for what? For G,
40 sin 30.
yes, sine 30 equals to 4, and we know our A will be 0.01 alpha, because if you write it down here, you make sure you write it down, eh? Okay, so acceleration for block B is R alpha, but the radius, use the inner radius, which is 0.01 alpha. Okay, all right. Next, we need to do for the pulley. Okay, now for the pulley, whoops. Okay, for the pulley, very simple. Uh, the hold on. For the pulley, okay, look at this diagram. This diagram for the pulley. So this is T2. Sorry, adik. This will be T1 and this will be T2. So let's say for the pulley, now for the pulley, we are going to assume anti-clockwise, okay, equals to moment effective. Okay, when you take moment, you need to do that. Okay, so T1 will be positive, multiplied by the radius, minus T2 multiplied by the radius, and equals to what? Equals to I alpha. Okay, now we need to calculate I. Okay, for the pulley. Now, when you want to calculate I for the pulley, which formula you want to use? The one that has I equals to 1 over 2 mr squared, or I equals to mk squared.
Dia ada bagi gyration ke?
Dia ada bagi tak?
I equal mk squared.
Yes. Why?
Sebab dekat soalan dia ada cakap radius of gyration.
Yes. Okay. So I equals to mk squared. So what is the mass of our pulley? 5 kilogram. And what is the k given? 0.2. Okay. So 5 times 0.2 times 0.2 dapat berapa?
0.2.
Yes. You get the 0.2 kilogram meter square. Please, when you write your equation and everything, please don't forget to include the units. Okay, practice when you're talking also to include units involved together. So I is 0.2 alpha. Okay, now what you have here, you have three equations. Equation 1, equation 2, and you have equation 3. So equation 1, 2, 3, what do you need to do? You need to solve it in order to get alpha. Very easy, right? What you need to do is equation 1 and equation 2 put in equation 3. Yeah? Put equation 1 and 2 into equation 3 to find what? To find alpha. Okay, alright. So can you please quickly do it and tell me what is the answer for your alpha? I give you 1 minute. Okay, dah? What do you get? What is the answer? Dah? Huh? Still ongoing? You understand, right? How to calculate alpha, right? All you need to do is T1, T2, put into equation number 3 and you can get alpha. What is your answer for alpha? What do you get? Do you get the same as me? 3.85 radian per second? Is it the same? Sama tak? Hmm?
Yes, Doctor.
Dapat sama? Okay, that is fantastic. Okay, now we can go to our next question. Oops. Okay, the next question is solve the equation of motion for the angular acceleration. So it means it asks us to find the angular uh, sekejap, oh ini this is the answer. Sorry, determine the angular velocity. Okay, now the question it wants the angular velocity. It means it asking you to find omega. Okay, how are you going to find that? Okay, what you can do is you you can use the basic kinematic equation. Omega equals to omega naught plus alpha t. Okay, so you need to find omega. Omega naught will be 0. Your alpha will be 3.85, and it says find the angular velocity at 3 seconds. So just multiply by 3. So 3.85 multiplied by 3, you get 11.6 radian per second. So that is the answer. Okay, senang je. Let's say they ask you to find the acceleration of the block. How are you going to find? Very simple. Just now, just now you have found the alpha. So all you need to do is calculate this. In case there's an additional question, find the acceleration of block A. So all you need to do is 0.2 multiply by the alpha that you have calculated. Okay, and then you will get the answer, and your answer will be in meter per second squared lah. Again, if they ask you to find the acceleration of block B, it will be 0.2 times alpha, which is 3.85. Okay, you'll get the answer. Okay, in case this is additional question. Okay, okay. All right, is that fine with you?
Yes, Doktor.
Okay, so we have done that question. Okay,
Soalan 2 tu, acceleration pulley tu macam mana? Yang
mana?
acceleration pulley tu
Ni?
uh,
Mana acceleration pulley? Ni,
solve the
angular
equation.
acceleration. Yang ni, this is this symbol here is angular acceleration.
Okay.
This symbol here is angular velocity. Remember? Okay.
Okay,
So
madam.
question number 2. This is answer for question number 2. This is answer for question number 3. Okay. And this one here is just additional. Let's say now they had an additional question and they said to you, find the acceleration of block A and B. This is how you solve it lah. Okay. Okay. So going, anything else you would like to ask?
No, Doktor.
Okay. So if we go back to our question, this one is the same question. If you notice this one, okay, I'm still sharing my screen, right? Can you still see? Can you see this question? January 2012.
Yes, Doktor.
Okay. So as you can see for this question, the question is the same. Using Newton's second law, express the equation for motion for the block and the pulley. Solve the equation of motion for the angular acceleration of the pulley. Here, calculate the acceleration of the blocks. Ni ada additional. Compare dengan tadi lah. And then next, solve the speed of the block A after T equals to 5 seconds. But this question kita dah discuss last week. Okay, if we didn't discuss last week pun, there is a previous pre-recorded video that I have actually sent to you for you to have a look and try and do. So supposedly you would have watched that video and would have gotten the solution and answer already. Okay, so oops, so sorry, we're back here. Okay, so we've done this. Okay, now this question, eh? Okay, I see it's already 5 o'clock. Do you want to stop now and do this question next week? I guess not saying anything means next week. Okay, since nobody said anything, I'm assuming that you are shy to let me know that you want to continue next week. Or can we proceed for this question today?
Tu
Uh,
tu. Tak shy.
continue next week.
Continue apa? Tak dengar, tak jelas. Continue.
Continue next week.
Okay. All right. So one of your friend decide that we continue next week. Okay. So we will continue this question next week and also this question. Okay. All right. So we have two questions to do next week. So make sure you copy this question also in your book. So we're going to try to solve this question. Yeah? So this question, um, first this question we're going to do next week. Okay, is the same is the same thing that we have done. Is just the different thing is dia tak bagi value, dia semua dalam sebutan V lah, MUK lah, N lah, M lah, R. But it's actually very simple and very easy. You can also try it by yourself at home. And then for this question, also is actually very simple and easy to do. Cuma this time dia ada dua pulley and then satu weight 10 kilogram and the other weight has at A has 12.5 kilogram. Okay, so we will continue this question on Monday. All right. Okay. Any other questions that you would like to ask before we stop today's class? So we'll stop now. I'll stop recording.